Hello, this is lesson 105, and it's using proportions to solve percent problems. So a proportion is a statement that shows that two ratios are equal, almost like equivalent fractions. So we're going to use that proportion thing to solve percent problems. Remember, we can make proportion butterflies, so we'll do that in just a minute. The first example tells me that 30% of the cars in the parade are antique cars. If 12 vehicles are antique cars, how many vehicles are in the parade in all? Okay, so I want to know, I know that 30% is the same as 30 over 100. So 30 of them are antique cars. The total percent is 100%. So 30 over 100. You know how I love my ratio tables. So thing, ratio, actual. So they want to know how many cars were actually in the parade. I know there weren't 100. So I'm going to put my little question mark there. And then they're going to use a proportion. So they're going to say 30 over 100 equals 12 over, and I'm going to put an X there instead of a question mark. That's usually the symbol for a variable in math rather than a question mark. Okay? So that's how I would set up my proportion. I know those two values are equal because they told me it's a proportion, right? Okay, so I'm going to make my little butterfly here. And I'm going to multiply the wings. So 30x, I'm going to multiply that, is the same amount as 1200, right? Would it be easier if I simplify that first? I think it would. I'm going to get the same amount since, again, it's equal. So I'm going to say 3/10 is the same as 12 over x. Do my butterflies. Ooh, that's a messy one. 3x equals 120. Okay, well, now I'm getting somewhere. So I want to get rid of that 3. I want it to go away because I want x right by itself. I want to say x equals this amount. So I'm going to divide both sides of the equation by 3. That cancels out. So then I get x equals 120 over 3. Remember, that's a division problem. So what's 120 divided by 3? X equals 40. So x is the total amount of cars in the parade, right? 40. So if there were 30 cars that were antique, you would have 100 total cars in the parade. But since you only have 12 antique cars, then you know you've only got 40 total cars in the parade. Does that make sense? So that's how you would use a proportion. I'm going to show you a little bit of a different way to do it. I can scale up and scale down. So remember how I use my ratio tables and I say 30 multiplied or divided by something equals 12? Well, it doesn't. You don't have to use this. This is foolproof. Always you can use a proportion like for anything. But I wanted to show you this because I know you'll get it in 6th grade. Okay, what if I divide both of those by 5? So let's go ahead and divide by 5 just to reduce it a little bit. And I want to end up with something that I could multiply to get 12. So 30 divided by 5 is 6. 100 divided by 5 is 20. Now how do I get from 6 to 12? Multiply by 2, multiply by 2, and I know my equal sign is 40 cars. So sometimes that works out pretty easily if you can see it in your head. Sometimes it doesn't. It's just another way to look at it. Okay, so let's go ahead and do example 2. They said that you had some team members, 40% played and only 24 did not play. So your 40% is out of the total. And so I know that 40% played, and that tells me that 60% did not play. So there's my ratio there, right? So it's 40 played, 60 didn't, out of 100. Okay, so that's easy. They want to know how many players I actually had. I can calculate how many total players there were in a minute, but let's go ahead and say 40 out of 60, there's my ratio, is the same as something, x, my unknown, over 24, okay? Let's go ahead and simplify that to see if we can use our alternate method. So let's divide both of those by 10, because I want to get this number, whatever that is, down to something where I can multiply. So that was 60 divided by 10 would be 6, 40 divided by 10 would be 4. 6 times what is 24? 4 times 4. Okay, so I see I actually had 16 players, 24 not players or non-players, right? So my total number of players, they didn't ask me, it's easy to find, right? Add them up. I had 40 players altogether. Let's try it this way. I'm going to simplify this fraction just to keep my math easier. You don't have to, but it sure does make your math much easier. Okay, so I'm going to cross multiply. I'm going to say 6x, and I can't do 4 times 24 in my head. Probably could. 96. Okay, so now I want to get rid of whatever's attached to the x, so that goes away. So x equals, and I can't do that in my head, so 96 divided by 6. Okay, 16. So I get the same answer both ways. Sometimes this is easier, sometimes this is easier. You just have to play with it a little bit and see. The last problem, example 3, says buying the shoes on sale, Nathan paid $45.60. And that equals 60% of the full price. So there's my full price, okay? So we know sale price and full price. Okay, and here's my total. Or 100%, I guess I don't need the total. So the sale price is 60%. There's my ratio. And my actual was $45.60, and they want to know the full price. Okay, so let's again reduce this before we do our butterfly proportions. So I'm going to say 45.60 equals 6 over 10. Does it matter which way I do this? It really doesn't. You can flip it because it's equal either way. So if I multiply that side of my equation, I get $456, and I probably should put a dollar sign in there, equals 6x. So I want to get rid of the 6. So I can't do that in my head. So I'm going to come over here, 456 divided by 6. It's like a square root sign, sorry. 7. Okay, so I found that the full price is $76. Makes sense how to do that? So proportions are really easy. This is one of those where I probably would not be able to easily reduce this, multiply it back to get that. So this is where your proportion always works, never fails. So set up your ratio tables. You may have to play around with it a little bit. You see here I didn't need the total. I just had a sale price and a full price. Sometimes you do, sometimes you don't. In this case, I did need the total because I had to figure out what percent was the non-players. But using a proportion is so handy for so many things. This is one of those things where if somebody says, when will you ever use math in your real life? You'll use this, I promise. All right, good luck.